All right, we have worked with addition, subtraction, and multiplication, and now we're going to do division of whole numbers. And division can be thought of a couple of different ways, but the one that I want to focus on is that division is actually repeated subtraction. Now let me back up for a minute. When we talked about multiplication and we had 6 times 2, what we were really saying is that we were adding 6 to itself 2 times to get the 12. If we said 6 times 3, we were adding 6 to itself 3 times. And although I didn't mention it in the previous video, multiplication is really repeated addition. Division is really repeated subtraction. If you had 20 donuts and you wanted to know how many sets of 5 there were, you would take away one set and another set and another set and another set. You would subtract 5 and find out how many times you could do that. And the answer would be that you could do it 4 times. Now, with small numbers, what you think about are your multiplication facts in reverse. If I said, what's 24 divided by 3, you would hopefully think of your multiplication fact that 3 times 8 is 24. That would give you the missing number of 8. That's another reason it's so important to have multiplication facts committed to memory. All right, let's keep going. The number that you are dividing, which represents the large mass of donuts you had, that's the dividend. How many groups the size of the group that you're dividing them into, how many 5s were there, that's the divisor. The answer you get is the quotient. So if you have 20 divided by 5 equals 4, that's the dividend, that's the divisor, and that's the quotient. If you write it out like you're performing the division, that's the dividend, and you can remember that because you're dividing, it ends in in. Okay, you're dividing into that. This is your divisor. Quotient is the answer on top. All right, so let's go ahead and begin. One more thing. I wrote these two problems this way. It also can be 20 over 5 is equal to 4. Dividend, divisor, quotient. Okay, so it's first, the 20 is first, inside or on top. All right, let's look at some problems. The first one, it says divide if possible. Okay, well, maybe we're going to run into something that's not possible. This is 47 divided by 47. This is the fraction form, which most people would look at that immediately and say, the bottom, the divisor, goes into the top 1 time. And if you did it this way, or if you did it this way, no matter how you look at it, the answer is 1. So I would choose that and put in a 1. Next, I have 54 divided by 1. It could be 54 divided by 1. It could be 54 over 1, or it could be this form. Anyway, 1 goes into 54 54 times. So the answer is 54. The next one, 0 over 6. That is 0 over 6 is one way to write it. 0 divided by 6 is one way to write it, or 0 divided by 6. If you had no donuts and 600 children, you would hand each child 0 donuts. Nobody would be happy, but you could perform the operation. The answer is 0. Now the next one, We have to be real careful here. This one is 7 over 0, or 7 divided by 0, or finally 7 divided by 0. You cannot divide by 0. 0 cannot be the divisor. If you had 7 donuts and somebody said, distribute those evenly among 0 children, that wouldn't even make any sense. There would be no division to take place. This is undefined. This is not possible. There is no answer to that problem. And you will get to choose in my math lab which it will be a multiple choice, kind of like the others. All right, now we're going to do a couple of division problems. If something goes in evenly, then we will not have a remainder. But if it doesn't go in evenly, we will have a remainder. Suppose, let's go back to the donuts. Suppose that I had 23 donuts and I needed to know how many groups of 5 there would be. And I divide 5 into 23. Well, it goes 4 times, and 4 times 5 is 20. But there are some leftover donuts that don't make a complete group of 5. This is called your remainder. It's the leftovers that don't make a whole nother group. And sometimes you use capital R and then write the remainder. And that's what we're going to do in this problem. If there is indeed a remainder, we'll see. All right, we're dividing 7 into 144. When we do long division and we don't have a calculator, we say, will 7 go into just the 1? The answer is no. That means there will be nothing written above the 1. Sorry about those. So nothing will be above the 1. Then, will 7 go into 1, 4? In other words, will 7 go into 14? The answer is yes. That means the first digit of my answer will go above there, and the second digit of my answer will go there. Nothing over the 1. All right, 7 didn't go into 1, but it goes into 14 2 times. Now you multiply. 2 times 7 is 14. That's your first, and we subtract. That cancels out completely, and we bring down the next number. Does 7 go into 4? No, it doesn't. So I'll put a 0, and I'll multiply. 0 times 7 is 0. Remember, that is my remainder. The remainder is always, always smaller than the divisor. So the answer to this problem is 20, 20, remainder 4. There are 20 groups of 7 in the 144, and then there's another group that only has 4 in it. All right, let's see what happens on number 6. I have 749, and I'm dividing by 7. Will 7 go into 7? The answer is yes. That means that I will have one number above each one of those. I will have a 3-digit answer. 7 goes into 7 one time. 1 times 7 is 7. Subtract and bring down only one number. Does 7 go into 4? And the answer is no, so put a 0. 0 times 7 is 0. Subtract 4 and bring down one number. 7 go into 49? Yes, 7 times. 7 times 7 is 49. I have a 0 remainder this time. My answer is 107. And you don't write remainder 0. All right, let's look at number 7. We're just going to practice our division. Might not be your favorite activity, but we do have to practice. I have 8 into 6,959. Does 8 go into 6? No. So there will be nothing above the 6. But it does go into 69. That means that my answer will be from there over. It will be 3 digits. Now, 8 into 69. Well, I think about all the multiples of 8. 8 times 8 is 64, and that's the closest one. So it will go in there 8 times. 8 times 8 is 64. Subtract and bring down one and only one number. Does 8 go into 55? Yes. Well, let's see. 7 times 8 is 56, so that's too big. So just a 6. 6 times 8 is 48. Subtract, and I get a 7, and I bring down one more number. 8 goes into 79. Well, it goes 9 times, which is 72. You can see how very important it is to just know your multiplication facts. And when I subtract, I get a 7. That's my remainder. Remainder 7. You know it's the remainder. There are no more numbers to bring down, and it has to be smaller than the divisor. So my answer is 869, remainder 7. All right, let's do one. Nope, sorry, we have 2 more. All right, we've got a 2-digit divisor. We've got 30 into 638. Now, 30. Does 30 go into 6? The answer is no. So there will not be a number in my answer above that. Does 30 go into 63? Yes. So there will be, that's the size of my answer. How many 30s are there in 63? Well, there are 2. 2 times 30, and don't hesitate if you need to go off to the side and multiply, you can do that. It is 60. Subtract and bring down one number. How many 30s are there in 38? Well, there's just one. 1 times 30 is 30. Subtract. That's your remainder. My answer is 21, remainder 8. Right now, I think we have one more. And I'm going to use plenty of room to do this one. I've got 83 into 7206. Now, we would all prefer to have a calculator, but we have to be able to do this without one. All right. The first thing you do is decide where will the answer sit up here. What will its size be? Will 83 go into 7? No. So there will be no number in your answer up there. Will 83 go into 72? No, it won't. Will 83 go into 720? Yes. I don't know how many times yet, but it will go in there. So this is going to be, my answer will be a 2-digit number. Now, thinking about 83 into 720, I have no idea, but I don't want to just guess. Just guessing will waste a lot of my time. So what I'll do is I will back up and just think about the 8 for a minute. And I will back up and just think about the 72. How many 8s are in 72? Well, 9. So that's my guess. I will say, I wonder if 83 will go in there 9 times. 9 times 3 is 27. Carry the 2. 9 times 8 is 72, and 2 more is 74. Oh, that's way too big. If I put 747 down here, that's too big. Okay, it did not go in 9 times. It was just a guess. So if 9 didn't work, let's try 8. 83 times 8. 8 times 3 is 24. Carry the 2. 8 times 8 is 64, and 2 more is 664. That will work. 664. Okay, so it is time to subtract. So I'm going to have to borrow. So now it's 4 from 10, which will give me 6. It is 6 from, I can't take 6 from 1, so more borrowing. This is now, and I squished it, this is now 11, so 11 minus 6 is 5. So I get a difference of 56, and I bring down the next 6, and it's time to almost make a guess again. All right, I have 83 into 566, and I don't know how many times it goes in there. So I'll think about the 8 and the 56. It'll get me close. It might not get it exactly right. And 8 times 7 is 56. So I'm going to guess 7. So is 83 times 7 a good choice? 7 times 3 is 21. Carry the 2. 7 times 8 is 56, plus 2 is 58. No, it was too big. But it does tell me that it's probably just one lower. That's how I make my guess. I guess by looking at just the 8 and the 56. Won't be perfect, but it's pretty close. 6 times 3 is 18, carry the 1. 6 times 8 is 48, plus 1 is 49. So I will subtract 498. All right, you can't take 8 from 6, so I'll borrow and put a 1. So 8 from 16 is 8. I can't take 9 from 5, so I'll borrow. So now it's 9 from 15, which is 6. That's my remainder. And I neglected to write that 6 up there. This didn't work. This didn't work. These were my multiplications that did work. The answer is 83 remainder, whoops, looked at it wrong. It's 86 remainder 68. Make sure that that remainder is smaller than your divisor. And that was the case up here. The remainder is smaller than the divisor. And the case here, the remainder is smaller than the divisor. Okay, so I know that long division can be kind of challenging, but I hope that this gives you a few skills to be able to do this effectively.